Hello everybody. I have come to school today, as you can probably tell. So here I am in the lab, it's still here, and I'm going to show you an experiment that we would have done as a demo, so you wouldn't have got to do this anyway because it's classed as a little bit too dangerous. But we're going to talk today about metals, and in particular one metal, which is this. This is magnesium. It's a kind of silvery metal, and it comes in strips like this, or it comes in little tiny little pieces like iron filings, but magnesium, so magnesium filings I guess. And it's very pretty. They use it a lot in fireworks, they use it a lot in things like when they're filming Harry Potter. If you put magnesium little filings into a flame, it looks all magical and lovely. So before I start that, I'm just going to go through this. So this diagram shows some information about metals, and it kind of touches on what I was talking about yesterday in my video, which is that there is a difference in how reactive metals are. Okay, so at the top here you can see some of the very, very reactive metals, some of which were on your knowledge organiser yesterday. So you've got potassium, sodium, lithium and calcium. They are all very reactive metals, and you can see these arrows say what they will react with. Okay, so potassium, sodium, lithium and calcium will react with just water. They'll explode if you put them in water. They will react with acids, and we're going to move on to reactions with acids later on this week or possibly next week, and they will react with oxygen. Okay, and they will react very violently with water and acids, and less so with oxygen, unless you give them heat, in which case they'll completely explode. I'm going to show you this with a different metal in a minute. So magnesium, as I just mentioned, is the one we're going to look at. Does not react with water. So if I dip this piece of silver metal into a pot of water, nothing's going to happen to it. It doesn't react with water. It will react with acid, as you'll see next week, and it will react with oxygen. Now obviously there's loads of oxygen in the air. At the moment I'm holding it, it's not doing anything. It's not reacting with oxygen at the moment. Okay, in order to make it react with oxygen, what I need to do is give it some energy. Okay, if I give it enough energy, those particles, the magnesium and the oxygen atoms, will have enough energy to react together and come together as a whole new compound. Okay, so I've lost my little clicker. Here we go. So when a metal reacts with oxygen, and not only metals react with oxygen, non-metals do as well, but this is specific, this bit, well the next bit is specific to metals. So what's formed is something called a metal oxide. Okay, so this is a type of compound, a metal oxide. It means that within that compound, within that thing that's bonded together different atoms, you're going to have a metal atom and you're going to have oxygen atoms. Okay, so a metal oxide is formed. Now you can form a non-metal oxide as well, but the next bit is going to be a little bit different. So metal oxides are what we call basic, and I don't mean like, oh my gosh, she's so basic, you know, like kind of Mean Girls-esque language. It actually means that they are what we call a base. Okay, now a base is a chemistry word, and essentially we're going to do more on this in the next few weeks when we look at acids and bases. It's kind of almost the opposite of an acid. Okay, and we'll talk about acids. They're quite nasty chemicals. Bases are something that you can add to an acid and it will neutralize it. So they're almost like the other end of the spectrum. And when we look at pH, you'll see that the bases are all the high pHs and the acids are all the low pHs. And neutral, kind of water, doesn't have an acid or an alkali aspect to it, or a base aspect to it, will be in the middle. Okay, so when you add an acid and an alkali, or an acid and a base, which is a solid, can be a solid form of alkali, together you neutralize, you end up with water essentially. So when we make a metal oxide, and I'm going to in a minute make magnesium oxide, then what we're doing is we're making a base. Okay, now as a kind of contrary to that, if you make a non-metal oxide, so something like carbon dioxide, they are not bases, they are acidic. Okay, so it's only the metal oxides that become bases. And if you've got no idea what I'm talking about, don't worry too much, because base is a word that we will do next week. But I think it's just worth mentioning now, and I'll obviously mention it again next week. So let's have a look at this reaction. Okay, so the magnesium plus oxygen reaction. Now when we write chemistry, let's see if my pen works after all this time. It does. When we write chemistry, chemical equations, we need to do so in a certain way. Okay, so the way that we write this out is just like this: magnesium plus oxygen. This is a bit like maths, but not quite. Now we never use equals. We're going to say makes with an arrow like that. That means a chemical reaction has happened. Okay, this arrow here. Now the other good practice is to make sure that everything's on one line. So if you're writing this on your book, you shouldn't go down to a line below. I think we've talked about that before. So magnesium plus oxygen, makes a metal oxide. So we put the name of the metal in. The name of the metal is magnesium. So it's going to make magnesium oxide. So we're taking some atoms of magnesium and some of oxygen, we're pushing them together, making them chemically bonded, and we're going to end up with an entire new substance, magnesium oxide. Okay, and I'm going to show you that in a minute. It's quite a violent reaction. It's very pretty. I don't know how it will come across on video, but I guess we'll see. So this then, let's just remind ourselves, is a metal plus oxygen, and we're going to make a metal oxide. Okay, so you could replace the name of this metal. From magnesium you could make copper. Copper plus oxygen makes copper oxide, for example. So let's just last thing say what these look like. So this is nothing to do with the chemistry. I'm just going to write in a different colour what these look like. So magnesium and is the metal, so it's a kind of silver solid, as I just showed you. The oxygen, as you know, is a colourless. Don't know if you can see this on the video. I'll have a look in a minute. Let's go for it anyway. Colourless gas. And the metal oxide, which I will show you in a second after I've done the reaction, actually makes a white powder. Okay, so it's very different. We're taking two very different things, a silver solid metal and a colourless gas. We're taking those atoms, we're putting them together in a reaction to make a compound. Remember, this here is a compound, and we are creating a completely new substance. Okay, magnesium oxide, which happens to be a white powder. It doesn't resemble a silver metal or a colourless gas in any way, and that is kind of the nature of chemistry. You often get things that are very dangerous, like sodium and chlorine. Sodium is a very, very dangerous reactive metal. Chlorine is a very, very poisonous and reactive gas. Put them together, you get table salt, okay, white salt that you would eat on your chips. Completely safe, completely different from those individual types of atom. So just for completeness then, I'm just going to add lastly the stuff I was doing yesterday. So magnesium, remember these are both and oxygen elements. That means that they would be made of just one type of atom. So magnesium, if I could look at it with amazing vision and I could see the particles, they would all be magnesium atoms. Same with oxygen. If I looked at oxygen, they would all be oxygen atoms, nothing else in there at all. But when we look at our magnesium oxide, then we would see a compound. We would see something with two types of atom in this case, magnesium and oxygen. Okay, I will do a little bit of the kind of particle diagram stuff shortly after I've shown you the reaction. Okay, so as I said, to do the reaction we need to be safe. So I've got my hair tied up, as you've probably noticed. I've now got my goggles on. I've got my Bunsen here already. Here is my magnesium. So I'm going to put it on a full blue flame to get a lot of energy to it. I'm going to hold it on the end, put it in here. I've got quite a lot, more than I should probably have. And you can see, there you go, it's reacting with oxygen now. Really, really white, bright, bright, bright. I'm not looking directly at it. Flame, okay? And there we go. And then if I push this up, don't know if you can see that. I won't touch it with my hands yet because it'll be very hot. But you can certainly see it on my tongs here. You can see there's the white powder, okay, on there. That is the magnesium oxide. Nothing like the original two things. And that's what makes chemistry so interesting, really. Okay, lastly then, very last part of this video, I'm going to draw some particle diagrams to show this. Now, basically what you need to do is you need two different colours, and you can do this in your book as well. So what shall I do? I'll do green for magnesium. So magnesium, I just draw a particle of it like this. Okay, so there's my particle that represents magnesium. And it's very easy, this actually. If I have a different colour for oxygen, so let's have, what haven't I used? I think they're all, let's have black, why not? So we've got oxygen represented by this black dot, and as you can probably guess, all we're going to do is make them join together. So rather than having our individual ones, we have one of each, and we join them together like that. There's our magnesium oxide, our metal oxide. It is a base, meaning it can neutralise an acid. That is all you need to watch, unless you are particularly interested in what the chemistry of this looks like in terms of knowing how many of those symbols to put in. Okay, so you can stop the video now if you are done with the reaction for today. Extension people, if you want to stay on, please, another minute or two, not very long at all, and I'll show you how we work out how many of these you get. Okay, so those of you that are still here, welcome. I'm going to now move on to the actual, this is called a word equation, this bit at the top, this blue one. I'm going to do the chemical equation, okay, the symbol equation. So you can look this up in your planner if you want to. I already know it. That magnesium, the symbol is Mg. Okay, I talked about it yesterday. Okay, plus we know that the symbol for oxygen is O. Okay, now this is very easy because, and I'm not going to go into detail as to why, because you will get a full-on proper chemistry teacher in year 9 to do this with you, because it's quite complicated working out which one goes with where, because you need to know more about the type of reaction that's going on here, which we're not going to go into, you'll do it later. But I'm just going to tell you that magnesium oxide is MgO. Okay, that is the symbol equation for magnesium oxide, MgO. Okay, it shows they're bonded because they're right next to one another. Now, unfortunately for us, we don't actually, this is not finished. Okay, and the reason it's not finished is because we know that oxygen goes around in pairs. Okay, and we also know that it's not MgO2, it's MgO. So what we have to do is split those oxygens apart. Now, the best thing to do with this, when you're working these out, is to kind of have a little tally. So if I have a little tally over here, Mg and O, and then I have to have the same number on both sides. This is called balancing equations, okay? So Mg on this side, currently I've got 1, O2, I've got 2 oxygens, okay? On this side, I've got Mg1, that's still right, but I've got oxygen 1, so it doesn't balance. With chemistry, what's on one side has to balance the other side. So I know that I've got to make this 2, and I know it's not MgO2, so I can't just add a 2 here. So the only thing I can do, because I can't put any little numbers in, is to put a 2 in front of it like that. Okay, so now I'm saying, okay, with this O2, I can get enough O's on this side, and I've got 2, to make the right compound. Okay, so 2 times O, even though it's in there, remember the big 2 at the beginning means 2 lots of MgO. Okay, 2 lots of MgO. So now I've got 2 magnesiums on this side and 2 on that side. So what do I need to do over here? Well, I've already got my 2 oxygens. So what I can do is I can just simply add 2 magnesiums. 2 magnesiums plus O2 makes 2 MgO. This will work now. Now the other thing that I should do if I'm doing a correct particle diagram is I really ought to do this properly. So 2 Mgs are represented by 2 green dots, not joined together because they don't go around in pairs. The oxygen does go around in a pair. So we can draw that actually bonded together like that. Okay, and then on this side we've got two MgOs. They're not bonded, the Mg and the O are, but the two MgOs are separate. So we can do the same thing over here. We've got one there and one here. And that is it. We have balanced our equation. Okay, we've done correct chemistry. Okay, thanks guys. I hope that makes sense to you. I'll put a little bit of follow-up work on the internet for you on the Google Classroom, and hopefully this has made sense and you're enjoying the new topic. Okay, bye-bye.